Let's talk tides. Now, tides are a fascinating force of nature. So much so that if the bodies are large enough and generate enough gravitational force, say like at Jupiter, Jupiter's gravity is so strong that it causes tides in the rock of its moons, most notably on the moon Io, where Io is so affected by the gravity of Jupiter that the rock shifts in tide and causes so much friction that the rock melts and is now known as the most volcanic place in the entire solar system, a moon orbiting Jupiter. Imagine. But here on Earth, the forces of gravity are not as strong. But they are strong enough to cause movement in the oceans, because the oceans, being liquid water, is much more malleable than rock, and therefore they do move about according to the positioning of the moon and the sun. So here's kind of how it might look. If the moon is sort of in your direction, then the oceans of Earth would kind of swing out in that direction as well, gravitationally drawn towards the moon. Even more so, if the sun is also in this direction, then you have a higher high tide. But what about on this side? Because if the moon and the sun are both on that side, what's dragging the ocean out in that direction? Because tides are always opposite sides of the Earth, high, high, low, low. What's over here is momentum. You see, Newton said in his first law that an object in motion wants to stay in motion. So as the Earth spins, and at its equator is spinning at 1,600 kilometers per hour, that ocean is being flung out and wants to continue in a straight line, but it doesn't, because the Earth's gravity holds it from going off. So you get a high, high on opposite sides of the Earth, which means that this way would be low tide. But the Earth is not static. It's dynamic. It's always changing its position. It's rotating in 24 hours on its axis. And so in 6 hours, it will have been here. And now, instead of high, high this way, it's high, high this way, and low, low this way. Okay, and then it will continue again. So as it rotates to this point, now it's low here and high here. And it continues to rotate, and now it's high here and low here. And it continues to rotate, and now it's high here and low here. And so there's 2 high tides and 2 low tides every day. Okay? And the fascinating thing about the tide is this. It's actually changing the rotation of the planet that we live on. I use a water jug with half full of water in it to demonstrate this. When you shake this, and if you slid this across a table, the jug, because of the sloshing water, will kind of move along to a stop. Now imagine if the mass of water was the entire Pacific Ocean, and instead of the walls of a jug of milk, was actually the shores of a continent. And now that massive body of water is sloshing up against the continent and then rushing away again and then sloshing up against the continent twice a day for billions of years. Okay, this is causing the rotation of our planet to slow down. And the fascinating thing is, in days past, billions of years in the past, the Earth is about 4.6 billion years old. The Earth's rotation was much, much faster. Now it's about 24 hours. It's actually slowing down. It's slowing down eventually to be a 25-hour day, 26-hour day. Why? Because of the sloshing of the oceans as the Earth rotates, being dragged towards the moon and away from the moon and such. And on top of that, okay, the moon has to move away, because there's something called the law of conservation of momentum. You see, if the planet is slowing down, it's losing energy, but energy can't be lost. So in order to make up for that, the whole system, the Earth-Moon system, has to get larger. And as a result of the slowing of the Earth's rotation, the moon itself is moving further and further away, at a rate similar to the rate at which your fingernails grow. So not very fast. I think that today the moon is about 1 meter further away than it was in the days of the Apollo era. They'd have to be on the rocket for an extra meter to get to the moon. So not much of a difference. But give us another million or a billion years, the moon will be a very small speck off in the sky, much smaller than we see it is today. This is the effect of the moon on Earth. Slows the rotation of the planet as it causes the oceans to slosh around up against the continents, which ultimately results in a moon moving farther and farther away. And that's the basic explanation of what tides are.